Okay, welcome to my class of science. With me, your teacher, Mr. A Plus. Um, we are actually continuing from where we ended in radioactivity as a topic. Okay, so for this lesson, we are going to look at radioactive decay. So we are looking at decay now. Okay. So let us quickly go through the few points that I've prepared for you and see how we are going to understand this topic as a whole. An atom is in a stable state as an equal number of protons and equal number of neutrons. So when an atom is stable, that means that particular atom has got uh, equal number of protons and neutrons. Okay. So now, however, when the number of protons and neutrons are not equal, the atom become unstable. Because for an atom to be stable, as I said in the first point, for the atom to be stable, meaning the number of protons and number of neutrons are equal. Now, when they are not equal, meaning an atom is not stable. Therefore, that atom is unstable. Okay, so now, what is it that we are supposed to do to make that particular atom stable? For an unstable atom to become stable and balanced, each nucleus emits radiation. So meaning that particular atom must emit radiation for it to become stable. The emission of these radiations is what is referred to radioactive decay. So that same emission is what is called radioactive decay. So you've understood what a radioactive decay is. Okay, this is the emission now of a nucleus to a given atom so that it can be stable. So that process is what is called the radioactive decay. So now there are three types of radioactive decay. One of them is alpha decay, beta decay, and gamma decay. Okay, or gamma radiation. So types of radioactive decay. Now I've listed them. So we are going to look at now each one of them detailed. So the first one is alpha decay. Alpha decay. Alpha decay involves the emission of alpha particle. Okay, alpha particle from the nucleus of a radioactive element. That is now a radioactive element. For example, when radium undergoes alpha decay, it emits two protons and two neutrons. Okay, two protons and two neutrons. That is radium. Remember, those of you are following in our previous lesson, I was trying to give you examples of elements that are called radioactive elements. Radium is one of them. So even here, we are now looking at radium as an example for alpha decay. So that particular radium, which is an element, contains alpha particle. So for it to be stable, it has to emit or give off or send out the alpha particles. So those alpha particles, they are the one that we are talking about here. Two protons and two neutrons. So it gives out or it gives off two protons and two neutrons. So as a result, the mass number of radium decreases from 226 to 222. Okay, the atomic number also decreases from 88 to 86. So now after alpha decay, radium changes to radon. Okay, and that radon now is going to be stable because it has given off the alpha particles. A stable element with mass number 222 and atomic number 86. So radium changes to radon when it undergoes alpha decay. Okay, So now the following image shows alpha decay of radium. So now I'm trying to give you now what I've explained here in an image form. Okay, so we have parental nuclide. So this parental nuclide you are seeing, this is the radium element, okay, with the mass number 226, then atomic number 88, radium. Then this one, when it undergoes, remember here we have daughter nuclide, so meaning it has undergone uh, emission. Okay, it has given off the alpha particles. So after it has done that now, the mass number will remain 222. Then the atomic number is going to remain 86. Okay, and automatically that one will become what? Radon. Okay, so radon plus alpha particle, we are going to have parental nuclide. I mean, we are going to have radium element. So what was given off is the 4, which is the mass number. Remember, mass number is this protons plus neutrons. So 2 protons plus 2 neutrons, that is 4, will be the mass number. Then 2 atomic number, which was given off, is the one which is down here. And what is this element? This element is irium. So irium is the alpha element or alpha particle. So it's the one that will be given off after radium undergone emission. Okay? So, or I mean undergoes alpha decay. It will remain with this one. Let's hope you've understood, and I'm very happy for you for your attention. Please don't forget to subscribe to my YouTube channel for more exclusive videos and physics. See you in the next lesson under the same topic.